Experiment name: rectifiers with filter and without filter. The aim of the experiment: to study off-wave and full-wave rectifiers with and without filters. Next, to find its percentage regulation and ripple factor. Operators required for rectifier experiment: diodes, resistors, capacitors, step-down transformer, digital multimeter and breadboard. Instead of resistors, we are using decayed resistance box. Okay, this is the circuit diagram of the off-wave rectifier. Voltage means here we are using digital multimeter. V0 means output voltage. Here we are using V0 digital multimeter. Step down transformer, diode and center tap transformer. This is grounded. The model waveforms. The tabular form. We have to measure VRL. RL means load resistance. By using decayed resistance box, we are measuring this VAC and VDC. And ripple factor, we have to find out what ripple factor and percentage regulation. So ripple factor and percentage regulation. We are observe here, we are using transformer. The main important component for half-wave rectifier transformer, which have two ends. One end is called primary winding, secondary winding. Primary winding we are giving 230 volts AC voltage. So be careful at this point. And this is secondary winding. Here secondary wiring we get AC voltage 9 volts, 0 volts and 9 volts. Middle one is ground. First one and last one is 9 volts. For half-wave rectifier we are using only first two. This wire is grounded and this is given for input. This diode input. The next one is digital multimeter. For here we have to measure both AC and DC. So for AC voltage, keep this one in this position. For DC voltage, change this slide AC to DC and keep this knob into voltage and 20 volts. And connections of the wire, volt, then ohm and common. This is the connections. Next, decayed resistance. Required components are step down transformer, diode, breadboard and digital multimeter and decayed resistance box. Now I am making connections. First keep the diode. You already know diode terminals, anode and cathode. Cathode terminal is indicated with silver coated. That terminal is called cathode. Okay, this is cathode. And keep one wire already grounded. 9 volts I am kept in the anode input. Next terminal, two terminals are. Next connections. Positive, this terminal is positive, this terminal is negative, this terminal. Positive terminal is connected to the diode, cathode, negative terminal is grounded. This terminal is negative. I am using red probe, but it is negative terminal. Common terminal is negative. Okay, I am connected to ground. Next, I have given 9 volts AC voltage to diode and given multimeter also. Next, DRB connection. DRB negative terminal is grounded and positive terminal connected to the diode, cathode. This is the connections of the rectifier. First tell me what is rectifier. Rectifier is it converts AC voltage into DC voltage. It's conversion of AC and by varying this voltage AC and DC. Observe the VNL voltage by removing this from the circuit. I removed both ways from the and observe VNL 3.05. This is called VNL. V full load means again connect this one. And ground. This is V full load readings. By using this knob, AC DC change and note down the remaining all readings by varying the decade resistance box 100 ohm to 1000 ohm, 100 ohm to 1000 ohm by wearing the decade resistance box and note down the remaining all readings. And next finally 1 kilo ohm. The general means keep capacitor to the at this point. Capacitor to without filter circuit and with filter circuit. With filter, keep capacitor at the output parallel to the decade resistance box at this point, 47 microfarad capacitor. Now wearing the resistance 100 ohm. First I am initially keeping 100 ohm. For 100 ohm, AC voltage 4.45 and DC voltage 3.49. We'll observe in record also. Record P full load means AC voltage. Sorry, this is the AC voltage 4. AC voltage 4.32 and DC voltage 3.38. This is AC and DC. Here ripple factor means equal to AC divided by DC. AC voltage divided by DC, we get 1.23. And theoretically of a rectifier, ripple factor is 1.24. In practically also we get near point. This is percentage regulation. Percentage regulation formula VNL minus V full load divided by VNL into 100. Full load divided by VNL into 100. Okay, VNL means without load. Disconnect load from the circuit. Remove totally from the circuit and measure the voltage in DC, not in AC. Measure in DC and observe, write it VNL reading. VNL reading.